All right. Now, there's some other kind of slightly odd feature to discuss. Okay, we've seen now multiple examples. And we saw multiple examples of what? Of the integral over the curve c of a function. So the curve c has to be given, and the function f of x comma y has to be given. And there's been a ds there. Okay, so this is what we've seen, and we've just the last three examples were at least writing out a Calc 1 style integral for people to do, right? Now, there's also the integral over c of f of x comma y dx and the integral over c of f of x comma y dy. Now, how do we compute these? Let's just talk about this one. All right. So it's actually going to be to compute the integral over c of f of x comma y dx. It's actually going to be integral a to b of f of still x of t, y of t. So that part looks the same as we've seen before. Now, earlier, ds had been replaced with this radical dt. Now, what we're going to do is dx is going to get replaced by x prime of t dt. So this part, let's just use new color in green there, is x prime of t dt. The reason for this, let's just think about this. It's that another way to write x prime of t is, of course, dx over dt. And then there's still this dt off to the side, so let's write that. And take a look at how this looks. It looks like the dt should cancel with the dt, and you just be left with a dx, that dx. Okay. So if there's a ds, you got to replace with this, and if there's a dt, if there's a ds, you replace with this radical then times dt. If there's a dx, you replace with x prime of t times dt. Now, what does that really mean? Let's actually work through using the last example. So let's actually take a look at the question we just did. So follow up. Okay, same general setup, but the integral, so same function, same parameterization, all the same stuff. Okay, but the integral over the curve c of x times sine of y, not ds anymore, but now dx. Following this, it's going to be equal to all the same stuff, basically. Okay, we're going to copy most of what's there. Integral 0 to 1. 3 plus 2t, quantity, times sine of 12 minus 3t. That much is all the same, but that's where the sameness stops, because that's ds and this was ds in blue. Now we need a replacement for dx. So this dx, what are we going to replace it with right here? Well, we need x prime of t, which we have right there. It was 2. So we'll have 2, and then just copy dt. So this 2 here is actually the same as the 2 that was right there. It's just there was more pieces. Let's just, for funsies, let's set up integral over the curve c of x times sine of y dy as well. So it looks very much the same. Integral from 0 to 1 of quantity 3 plus 2t times sine of 12 minus 3t. Now, the difference is right here where there's a dy, we're going to need, you might guess it, yeah? We're going to need dy dt, or y prime of t, either way you say it, so times dt. Okay. So great, we've set these up. These integrals could be computed if you really wanted to. Now, the real thing to really talk about is, what the heck do these mean, right? So great, we converted this integral into a Calc 1 style integral, and we can leave it to the Calc 1 student to compute this. But what is this? What is this? I'm so glad you asked. So I'll go back to the app. So using the function in blue, the graph of the function in blue shown here, the yellow curtain was the line integral that we'd been looking at most of the time over this curve, right? But if you take this yellow thing and you just you Hulk smash this, you project it against the x-axis. See this purple thing here? It's completely flat. See the yellow, even looking from here, you can see it looks like it's thick because it's rippling back and forth this way. But if you take this and you project it onto the xz plane, you get this completely flat. In fact, based on our view right there, we no longer see that purple. This, the area of this purple thing, that is the integral over the curve of f of x comma y dx. And then when it's flattened, I don't know if I can, so yeah, maybe from back here we can see this purple one over here, the one that's been projected onto this green axis is the y-axis. Can I see it from here a little bit? Maybe I can turn off the surface. Can I do that? Yeah, that's better. Okay, so then, yeah, this purple one over here, the one back here, that's the integral of f of x comma y over the curve C with respect to y. Okay, so I should have done that earlier. Apologies. Okay, there's the graph of the function. Hiding it is actually very helpful right now. So in yellow, you see the original one with the ds. This purple one over here on the left, that's dx. That's the integral that ends dx. And then the area of this other purple region back here, that's the integral of f of x comma y over the curve C dy.